So welcome to this newscast from the Euroluna team here in February 2013. We had the last newscast around New Year, and there's actually been significant progress since that time, and I will do my best to give you an overview of that right now. Now, first of all, we have had continuing interaction with the Indian Space Organization. They're called ISRO, but we're talking to the commercial arm, which is called Antrix, and we are right now in the process of defining the launch adapter, which is basically a box wherein we have to fit our ROMIT-1 satellite and ROMIT-2, and they have a different way of doing that technically than the other launch adapters we've been looking at. So there's some details to be sorted out on that. They have offered us space on board one of their launchers in January 2014, which should just about fit us for the testing phase for ROMIT-1 and ROMIT-2. The details are still being finalized, and I hope to have more news of that over the next months or so. The second news is more technical, and that is linked to our ion propulsion engine, where we here in January had a significant test in Vienna with the ion propulsion unit inside the vacuum chamber and our test equipment outside. It's one of those tests which we also had one in October, November last year, where we were not so happy with the results. It didn't quite work out in October, November last year the way we wanted it to go, and therefore we went home and had long work on what should be done and how we could do the next tests. And I'm very happy to tell you that we were very successful in the last tests we did, and we managed to run the ion engine on a very limited power, exactly like it will be in our ROMIT-1 application in space. The next coming test on that one is to go again, this time with the flight hardware, and have the flight hardware still standing outside the vacuum chamber, but controlling everything that goes on inside the vacuum chamber from the actual flight hardware that will go up on with ROMIT-1, hopefully January next year. So that's the news on the ion propulsion. There is a bit of extra news on that as well. Those components, those high tension components we are planning to use, comes from a company called Pico, and we've had contact to them on how that component is working in space, and they have actually told us that the material that's been used here is approved for space applications by NASA. We've cut one of them up in order to see what's inside. Now this is a DC to DC transformer, so what we have is a little transformer inside and then some fast switching on both the entry and probably also on the exit. Without knowing the details, we just cut it up in order to see how it might function also in vacuum, which is very important to us. We've also taken a component to actually test in a vacuum chamber, and that went very well. Not that we went to very high vacuum, we went down to some millibars, or 0.3 millibars for a week, and gave it quite some temperature stress. We went down to -60. And all that worked very well, and the components came out of that in functioning order. So right now what we're doing is that we are expanding on this operation with mounting these on the actual flight hardware where they should be going, which will, because of the temperature of these things, will be metal, aluminium of course. These things in our last tests, these components had a temperature of around up to 105 degrees when they were operational for a long time and under stress, and the recommended temperature, maximum temperature, is just around there. So for the space application we need to have such a component here fixed with something on an aluminium plate in order to make sure that we get the heat transferred away from the component. But that has put us into a very, let's say, positive and hopeful mode that we can actually do those tests in not so far a future with our actual flight hardware. Well, I have one more thing actually. In the meantime, we've also continued with some of our orbit calculations. We have discovered that some of our magnetic fields measurements on the way, we need an additional information in order to give an idea about the position we are in, which is some of the things we use for our positioning on the way. And it turns out that the direction between our ROMIT 1 and the Sun is actually enough, together with a measurement of the magnetic field in the current position and current place, should be enough to actually pinpoint our position, not very accurately, but accurately enough for what we are doing. This is mostly for the attitude control of the spacecraft, where the rotation speed is important, because that's what we want to control with our onboard navigation system. And for that, I think I'm nearly there. The last comment from my side may be that we're looking forward to the meeting in April in Chile, where all the teams will be together again. We have some unfinished discussions with the X Prize Foundation on the X Prize, the Google Lunar X Prize payload, which comes in a size which is not very compatible with a CubeSat application. And that's something where the ball right now is in our court, and we have to write to X Prize formally to express the alternatives we would like to have on that one. We've also been audited for the last quarter of 2012 on our YouTube videos and our blog production, and we have been found to be in line with the regulation and the decisions in the master team agreement. So that's fairly good news. Now, thanks for today.